Topic is asymmetric synthesis in part 7. In part 7 I'll be dealing with the enantioselective synthesis, wherein I'll be dealing with certain reactions. So in the before video, what I have done is, there also I have done the enantioselective synthesis with the help of certain reactions. Now again you have to continue with that at next upcoming reactions. Okay, so moving on to the continuation of the topic, like SS-CHIRAPHOS. Okay, in your syllabus it has been given. So SS-CHIRAPHOS, it is an important chiral phosphane and it is the butane derivative. Okay, so 2,3-bis diphenyl derivative is known as your SS-CHIRAPHOS. Here you can see the structure over here, diphenyl derivatives. Okay, so moving on to preparation, you have to take the alcohols, dialcohols, methyl substituted dialcohols in, and then if you filtrate it with the tosyl chloride. Okay, if you filtrate it with the tosyl chloride, what happens here is, there is a cleavage of HCl molecule, and then tosyl group just goes and sits over there, binds over there, and then what happens, tosyl group is will act as a good leaving group. So there is a cleavage of the good leaving group as OTS minus, and then the phosphine group just goes and sits over there, will result in this one, bis diphenyl derivative. Then moving on to next reaction. So here, if you will see here, if you will take that biphenyl phosphines and then if you will treat it with the RHCl3, okay, rhodium chloride, in the presence of THF and hydrogen catalyst is, and CO2 Me C double bond CH2 NHCOCH3. In the presence of this, all of this reagent, what happens, first stage there is a formation of the transition state. Okay, after the formation of the transition state, so remember, if it is undergoing a rephase attack, if it is taking place, you are getting the transition state which is favored. C phase, which is you are getting the transition state unfavored. You have to check with this moiety, okay, which phase it is going and attacking. So this is your main reagent, and wherein the attack will takes place. After the formation of the transition state over here between the oxygen and metal, there is a formation of one complex moiety, and then what happens here is, there is a cleavage of whole of this phosphine rhodium complex by the formation of your major product, that is CH3CO, then again NH, CH, this will gets changed to CH3. Okay, there is a shifting of the bond over here, you will generate the carbon ion and then you will abstract the proton. So you will get NH, CH3, CO2, Me. Again, this is your in the R configuration, which is your major product. Okay, so moving on to next, if you will see here, there is another possibility wherein you will get the transition state unfavored. See the positions over here wherein the attack takes place. So if you will see here, that time what happens, you will get to know CO2 Me is facing towards your right side in the transition state favored, wherein the transition state unfavored, it is facing towards your left side. Okay, so if you will see here, there is again the formation of the complex between here. Here if you will see, the oxygen is facing inside. Okay, so after the removal of all this rhodium complex, there is a formation of your minor product, that is your S configuration. Okay, R is your major product, S is your minor product. And then moving on to next, RR DIOP. Okay, DIOP, DIOP. Okay, so this is also known as 230 isopropylidine 2,3-dihydroxy 1,4. This is a different name, like this can also be called as the diphenyl phosphinol butane. Okay, and then it is an organophosphorous group, wherein you can study in the organometallic compounds, that is organophosphorus, organoseleniums, organotelluriums and all. Okay, so here you are taking the organophosphorus groups that are used on your chiral ligand, okay, in the asymmetric reduction structure. So here if you will see this, in general if you have to say, this is your diphenyl phosphinol butane. Okay, So you can see here dioxin structure, right? If you remember, in general you can see the dioxin structure. Okay, so substituted dioxin structure, that if you will take and then if you will treat it with the rhodium chloride trichloride in the presence of the hydrogen catalyst. Okay, and then again same reagent you are treating, CO2 C double bond CH2 NHCO CH3. Just put a bond over here, I have forgotten. So after that what happens, during this reaction again you will get back two products, one is your major and one is your minor. Here your S configuration is your major product and R is your minor product. Here you can differentiate all the reactions which you have studied in the enantioselective synthesis. So for alpine borane is binyl H, and then this both are similar and this both are similar. So if you will first write like alpine borane is binyl H to avoid confusions, and then rephase you are having the major product and C phase which is having your minor product. Again here if you will see, S is a major and then R is your minor product. Okay, S configuration, R configuration. And then moving on to today's part, which I have dealt with this topic, CHIRAPHOS and DIOP. So if you will see here, R is your major product, okay, S is your minor product, wherein here S is your major, R is your minor. In the simple way, if I have to say, whenever you will see SS-CHIRAPHOS, remember S, opposite of S is R, right? So opposite of this, remember that will be your major product. S will whenever S R, okay. So whenever you will see SS-CHIRAPHOS, remember R will be your major. When you will see R DIOP, at that time remember S is your major product. Okay, so moving on to next slide, next topic, that is your alkylation of ketones through hydrozones. So what happens here is you are taking the, I will speak you about this. So you are taking the 1S1 amino 2 methoxy methylpyrrolidine, which is also known as SAMP. Okay, SAMP, and that SAMP enantiomer is nothing but RAMP. Okay, depends upon the configuration. That will be used to chiral auxiliaries in very efficient enantioselective alkylation. So here basically what you are doing is you are alkylating either a ketone or an aldehyde. So what happens here, you are taking the pyrrolidine ring and then substituted pyrrolidine compound, and then if you will treat it with the diethyl ketone, okay, at that time you will get, in the first step you will get back your hydrazone molecule. Well, after the formation of your hydrazone, upon treatment with the LDA, that is your reducing agent, what happens here is there is a formation of one lithium with the oxygen. There is a formation, first there is a formation of carbon ion over here. Okay, here the carbon ion is generated, CH2 minus, and after that what happens, the lithium will just go and bind over here with the formation of one like intermediate, and after that what happens, you have to treat it with the propane iodide. At that time what happens, if you will treat it with the propane iodide in the pre-oxomofacial attack, okay, the attack will takes place. At that time there is a cleavage of your lithium moiety. This iodide molecule will get cleaved out, minus will go and attack to this point, CH2 group, and there is a cleavage of LiI, that is your lithium iodide gets cleaved out, resulting you in this molecule, that is your C3H4. Okay, and after that once you'll get back this molecule, and then you have to do the hydrolysis upon treatment with the methyl iodide. Once you'll treat it with this, at that time what happens, this molecule which is present over here will go. Okay, this whole moiety will cleave out, resulting you in the ketone structure. So after that there is the attack over here, and then I don't think so I should show the mechanism. Upon hydrolysis you will get back your alkylated ketone molecule. Moving on to enantioselective alkylation with the chiral PTC. PTC is your phase transfer catalysis. So here the chiral PTC will be like crown ethers you have studied, right? Crown ethers in which you are taking the ammonium salt, phosphonium compounds, and that will give you the enantioselective reactions, which is very poor. And then recently, if you are doing the alkylation of 2-phenyl indinone, okay, 2-phenyl indinone, which has to be catalyzed by the benzene in cinchoninium cation. So when you will see here, there is a generation of the cation, and this is your queen nucleidine ring. Okay, this ring is known as your queen nucleidine ring, in which will lie in the plane. In the same plane it will lie. And then if you will take the phenyl indinone, 2-phenyl indinone substituted, chloro substituted at phenyl is over here, and then if you will treat it with this crown ether, at that time what happens, in the presence of CH3Cl alkyl chlorides, upon treatment with the base, you will result in this product. Okay, so here what happens, if you will see, only this is your change. Okay, so here the methyl group goes and attacks. First there is a formation of the complex moiety. I will show you in the next slide the interaction, the pi stacking interaction between this and this. There is a benzyl cation formation over there at synconium cation, and then that will lead to the formation of your product. Okay, that is your resulting in the enantiomeric excess of 92%. The phenyl goes down in the below the plane, and then methyl group comes and attacks above the plane, so you will result in this molecule. Okay, and then moving on to next slide, if you will see carefully, this is your reagent, right, crown ether, and then this is your starting material. So what happens here, you have to show the attack between this diphenyl group and the chlorine molecule CH2. Okay, so here there is a pi stacking over here, and that phenyl with this phenyl, and then this phenyl molecule of this side towards your right of your nucleidine attached Q-nucleidine ring, which is attached with the phenyl ring again, that with this starting material. So what happens here is, first the oxygen which is having the minus charge, okay, that will come back, and then there is an attack of this bond, alkene bond to the CH3. There is a cleavage of your Cl molecule, that will result your methylated compound over there. Okay, and then moving on to next slide, it is the enantioselective reactions with the help of the Micheal addition. So here what happens, the Micheal addition takes place, there is a generation of an alpha beta unsaturated amines. Okay, so here you just go through these points. I will tell you, I'll explain you. So here you are taking the alpha beta unsaturated carboxylic acids. Upon treatment with the thionyl chloride, what happens here is, there is a cleavage of your this OH gets substituted with Cl. Okay, so what happens here, HSO2, and then one of the Cl will goes off, and then you will result in the chloride moiety over here. And after that you have to treat it with the amines, chiral amines. Okay, so once you will treat it with the amine compound, what happens here is, the attack will takes place, HCl molecule again gets cleaved out, resulting you in this adduct. After the formation of this adduct, what happens, you have to treat it with the Grignard reagent. Upon treatment with the Grignard reagent, there are two possibilities. One is your front attack, one is your back attack. So in the front attack, if you will see, you know the Grignard reagent is having RMgX. R will have negative charge, Mg plus. Okay, so this minus charge of this methyl group will go towards your upside, that is your front. So you will get back this molecule PHCH3 in the upwards, and then once it will go and attack, at that time this bond shifts, and then over here this double bond shifts, make a double bond over here, and then the carbonyl carbon which is present over here, carbon and oxygen bond, this will shift, resulting you in the minus charge in the oxygen atom. Once you will get back this structure, this minus charge will again go back, and then you will get the carbocation. Okay, so what happens, the carbocation, you will generate minus charge over here. Again you have to abstract the proton. Okay, upon protonation, upon hydrolysis and protonation, what happens? You will result in the normal CH2. Okay, after that you have to do the hydrolysis, which CH3O plus. At that time what happens? The bond will break over here, C double bond O, and then the OH will come and sits over here, and then one of the H will come over here. Okay, so this is your minor product. And then if you will go back over here, again same thing happens. There is a backside attack. When this CH3 minus will comes and attacks towards your back, this bond shifts, resulting you one of the double bond shifts over here. So here there is a generation of a new bond on, and then this bond shifts, resulting you in the O minus. Once you will get back your O minus, again this charge shifts, make a bond, this bond shifts, make it as a carbocation, and then upon hydrolysis, addition of the proton on this, it will abstract the proton, you will get back your CH2. And then after that what happens? Again the hydrolysis takes place. OH will come and bind over here with the cleavage of this bond. Okay, and then you will result H over here, NHCH3, and this whole molecule. And this is your major product, this is your minor product. Thank you. If you have any doubts, please ask me in the comment box. Like and subscribe the channel.